probability. We're going to talk about the at least one event. And also the conditional probability. Okay. So this one meaning one or more. Okay. Find the probability of event when we have additional information that some other event has already occurred, and this event has impact. At least one is equivalent to one or more. The complement of getting at least one item of the particular type is getting no items. So probability of at least one. The complement event is none. None. Okay. So this is how we tackle the at least one event using the complement event. To find the probability of at least one, calculate the probability of none and subtract it from the one. Okay. And let's look at this example. So top 4 surprises. X data DVDs in lots of 50, and then they have a reported defect rate of 0.5%. So the probability of disk being defective is 0.005. It follows that the probability of disk being good is 0.995. So what is the probability of getting at least one defective disk in a lot of 50? So again, this at least one. Defect. So we're using 1 minus probability of none. No defective disk. And if you look at the probability, I mean they have to be all good. So here we're going to do all 50, right? Probability all 50 good. DVD disk. And here first one being good will be 0.995 raised to 50th power. So let's see what that is. 0.995 raised to 50 turned out to be 0.7783, and the difference is the probability for at least one defective. This is going to be approximately 0.222. So we have 22.2% of chance we're getting at least one defective rate disk in a lot of 50. And let's move on to conditional probability. A conditional probability events, it's basically equal to probability of A and B over P probability of A. Probability of A or B meaning A intercept B over probability of A. So this is a given condition. And this notation indicates probability of B, event B given that event A occurs. Conditional probability of event B occurring given that event A has already occurred. And conditional probability could be found by assuming that event A has occurred and also has impact on the event B. And let's take a look at this condition 2 by 2. This is what we call 2 by 2 continuous table. This table will have 2 rows and 2 columns. Okay. Now for this conditional conditions table of 2 in a row, we have subject using drugs, subject using drugs, subject does not use drugs. So we have total of 50 subjects who are using drugs, we're adding 44 and then 6. Subjects who do not use drugs, adding 90 to 860 is 950. And if you look at a column, so this is the total on the row total, column total. First column is positive test, positive result, drug test, 44 plus 90 is 134. Negative drug test, it will be 866. If you combine these two numbers or those two numbers, combine row total or column total, you get 100,000. Meaning they survey 1,000 subjects. They break down the different categories and present in a contingency table. Now let's find the probability that a subject. Okay, first of all, refer to the table to find probability that the subject actually used drugs, given that he or she has a positive test result. So we are talking about probability of. So this is a given condition. Positive test result. We're talking about using drugs. So basically you look into the all the positive test results. If you look at it, we have 134 total positive test results. Out of all of those 134 positive test results, 44 of them use drugs. Okay. So basically we just find out the percentage of the people who use drugs under this category of positive test drug test. So it'll be 44 over 134. And if you simplify this, it will be 22 over 67. So this is the exact fractional answer. So basically conditional probability, you should always look into the given condition. This is a given condition. Look into that category and look at the detailed breakdown of that particular category. Now one more question here, find the probability that a subject actually does not use drugs. Again, this is a given condition. Not use drugs. Given that this vertical line indicates given condition, negative test result. Okay, again, you look into all the negative test results, which is this. Okay, negative test result here will be 860 plus 6. Out of all of that, we look for the subject who do not, percentage of the subject who do not use drugs. 860 of them do not use drugs, so it's 860 over 866. If you reduce it, you're gonna get 430. Go top and bottom by 2, 433. Okay, and that's what we call a conditional probability. And probability of even A given that even B occurs, and probability of even B given that even A occurs are not the same. These two are not the same. Not the same as probability of even B given that even A occurs. They mean different things.